Hey guys, Kevin here. Let's have a look at classes and inheritance. So what are classes, you might ask? For that you need to understand the concept of objects. Now what is an object? An object is something in Python which has member variables and a behavior associated to it. So let's say I wanna create a student, alright? So student will have a name, it will have its age, gender and marks, right? So now a student is an object with four member variables, alright? And I can create a student using a class. Alright, so what I'll do is I'll write class student and then I'll define these four variables under it. And then each time I want to create a new student in my class, I'll just say student equals to S1 or student 1 equals to class equals to the student class, S2 equals to student, S3 equals to student, and each time with different parameters and values. Now to create these classes, this is the syntax for it, but this is just for a vague class where you have predefined the value for it. If you want to create a class where you can create an entire database, you need a function called init. Now what init does is that anytime a class is initiated, this function is always run first, alright? And what it does is it assigns values to object properties or other operations that are necessary to do when the object is being created, alright? And a self parameter is also used as reference to the current instance of the class and is used to access variables that belong to the class, right? There is also a string function str which controls what should be returned when the class object is printed as a string, all right? We are gonna code this out and here's the format for it, right? So let's just take the example of a student and let's code it out. So let's sort of head on over to collab. Let's give a title, right? Let's do class, defining a class, right? Let's define a class called student, all right? Let's put a colon. Oh, let's put a colon. Let's write enter. And over here, first we'll define the init function, all right? Single I. And over here, first of all, you'll have a self parameter. Now, what this self parameter is, it is an instance in the class, all right? If we have a look at the definition, a self parameter is used as a reference to the current instance of the class, and it is used to access variables that belong to the class, all right? So what it does is that, let's say I'm talking about student one, what it will do is it will create an instance of the entire class, and then all the variables can be given under the name self dot variable one, self dot variable two, all right? So let's do self, let's do name, age, gender and marks, all right? And then we'll obviously have to write def to define the function, and inside that what we'll do is we'll do self dot name equals to name, right? Self dot age equals to age, self dot gender equals to gender, and self dot marks equals to marks. Now with this, what I did was that whenever I'll call or whenever I'll create a student, each time I'll give these values as inputs, alright? And now in the entire class, I can access these at any time. So let's say I'm creating a new function, def print, alright? Now over here, if I was not using an init function, I would have to write name, age, gender, marks, everything again. Now I don't need to do that if I've used the init function, where I'll just do print uh, the details of the student are, alright, and then we just do print self dot name, print self dot age, alright. And let's now create our student, right? So let's say stu underscore one equals to student, alright? We are calling the class, then we're writing Kevin, 19, male, and marks would be, let's say, 90. All right. And then if I were to do how to run it, we can run it without any errors. And then next thing what we can do is we can say stu_1 dot name. All right. Let's print that. All right. Print stu_1 dot name, and you can see we can access Kevin right from there. We can also do this. We can also do print. We can also call stu_1 dot. I should name this print. I should name this print underscore det, because I realized print is a keyword, right? Print underscore det, and let's just run that, and you can see that all the details of me are printed over here. What I could do over here is I could create another student, student2, and it could be John, or let's say David. His age is 20, male, and he, let's say, scores 85. All right. And if I were to do over here student2, and if I were to run that, I get all the details of David. All right, his age, his age, gender, and marks. So that is basically how you can define normal classes, and that's how classes work in general. Now, one another additional thing is the string function. All right. So usually what happens is if I were to do something like print stu_1. All right. Let's have a look at the output. I get this weird output. All right. What it does is it gives me the address where this is stored, and I don't want that to be printed. All right. I want certain things to be printed which can give me a meaningful output. All right. So what I can do is I can create a function obviously with the self tag. All right. And there I could do return f and then the entire string that I want to return. All right. So what I'll write over here is I'll say the name of the student is, right. Let's have a look at the format. Right. Over here the name of the student is self.x, self.y, whatever you want it to be. So in the curly brackets, self dot name, their gender is self dot gender, their age is self dot age, and they scored self dot marks. All right. And now whenever I were to run the again, if I were to run print student1 now, I'll get this perfect statement, which is the name of the student is Kevin, their gender is M, that is for male. All right. So I could enter male over here. Their age is 19 and they scored 90 marks. All right. If I were to print student2 over here, and if I were to run that, the name of the student is David, their gender is M, their age is 20, and they scored 85 marks. All right. So that's the beauty of the string function. All right. So we are now done with yeah, one last thing that we can cover is if I want to access a particular value. So let's say I want to change David to John. Right. So what I can do is I can do stu_2 dot name equals to John. All right. And after that, if I were to print stu_2, let's run that. The name of the student is John, the gender is M, 20, and they scored 85 marks. What we did was we accessed the name of the student, student.2, and their name was first David, right? And then we changed it to John. So now it has been changed to John, and that is how we can access the particular name of any student, all right, and how we can make changes to them. So we are done with classes, and now we'll have a look at inheritance. Now, what inheritance does is that it allows us to take certain things from one class into the other class. All right, we can have a parent class and a child class, and it allows us to define a class that inherits all the methods and properties from another class. So let's say that I'm creating a school database. All right, now in a school database, there are certain things that, let's say I wanna create student and teachers. Right now, some things are common between student and teacher. We have name, age, and gender. Those three things will be used in both the databases. Right, each student will have their name, age, and gender, and each teacher will have their name, age, and gender. What a student will have is marks, and what a teacher will have extra is his profession or the subject he is teaching. All right, so what we can do is, let's create inheritance. All right, now let's do diff person. All right, not diff, sorry, my bad, class of a person. All right, and on that we'll define a init function, self, name, age, gender. All right, and I'll just copy this so that it's easier for me. All right, fair enough. Each person has a name, age, and gender. Now what I'll do is I'll create another class called student, and I'll access, I'll inherit from the person database. All right, fair enough. Let's define an init function. All right, over here I'll just do self and all the things that I want. So I want name, I want age, I want gender. However, I want another thing. I want their marks as well. So I'll write marks over here. All right, and then what I'll do is, inside this I will give a callback to the init function present in the person class. All right, so any function that I want to call from the person class, I'll just be like person dot copy this entire thing. All right, and self dot marks equals to marks. Okay, so what I saved myself from doing here was that, had I wanted to create another class with student, I would have to write these lines again. All right, I would have to write these lines again. Now I don't have to do that. I just have to do this one line and I'll get my desired answer. All right, let's do it for our teacher as well. All right, let me just copy this. That's self dot subject equals to subject, and over here I need to change this to subject. Let's just check once if we have done it correctly with the, yeah. All right, now what I can do is I can create stu underscore one equals to student. In the bracket I'll write Kevin. I'll just copy this. All right, all right, and then what I'll do is I'll do teach underscore one, and I'll call the teacher class. All right, I'll name him Jack. All right, Jack is, let's say, 30 years old. He is also a male, and his subject is physics. All right, now if I were to uh, we need to write a string function as well, right? Let's just copy this print text function, right? And that should do the trick as well. All right, and I'll do stu underscore one dot print underscore det. All right, and teach underscore one dot print underscore 10. Alright, so as you can see, let's put a blank print statement over here so that we have a separation. But what we did over here was, instead of repeating these 3 lines of code multiple times, we just called that particular class and then we used it in our student and our teacher uh, class. Right, so basically we just saved a lot of memory. Right, each time name, age and gender was common, we would have to create, if we hadn't done inheritance, we'll need to create self dot name, self dot age, self dot gender at both the places. And what inheritance did was, it made our lives easier. Right, so that's inheritance for you. There's also this one feature where you can do super, and what super basically does is that, let's apply it over here. I'll just do super over here. All right, super, and I won't have to write self over here. I'll just have to do this and it would work perfectly fine as well. All right, what super did was, it did the same thing. I just didn't have to write self. It inherited everything from the parent class, right, on its own. So that's a super function. You can use that as well. Now there are many types of inheritances. All right, there is single inheritance, you have multiple inheritance, you have multi-level, hierarchical, and hybrid. I'll explain all of them. So what was single inheritance? Single inheritance is when you have one class, one parent class, and one child class. All right, there's multiple inheritance where one child class inherits from two parents. All right, so let's say name, you have a class called name, and you have a class called age, and then you're creating a class called person, and then you're using name, age, and putting their gender. All right, so that's multiple inheritance. Multiple inheritance means multiple parents. All right, multi-level inheritance is a grandfather, a father, and a son. Hierarchical inheritance is that one parent has 3 children, all right, 2 or more children. So that's an example. So what we did over here was, we took person and we created 2 branches, student and teacher. That was hierarchical inheritance, right? And then there's hybrid inheritance, which is a mix of all. So let's just head over to coding, and I'll just write a short code so that I can explain. So let's do single inheritance. All right, let's create a function. Let's create a class called parent, right? And inside the parent class, what we'll do is, we'll create obviously init function. We'll write self and parent name. All right, and inside that will be like self dot parent underscore name equals to parent underscore name. All right, and then what we'll do is, we'll do a class child. Will be like def init, and obviously we have to call the parent. So parent over here, and self comma child underscore name underscore parent underscore name. All right, and we'll need to call the parent function. So let's do parent dot, let's just copy this function entirely, and self dot child underscore name equals to uh, child underscore name. All right, I need to put a indentation over here. Yeah, we don't need this colon over here. Yeah, so now what I can do is, I can say child underscore one equals to uh, child, and then Kevin, and let's say John. All right, and if I were to uh, this, I'll just print I'll just copy that print function as well, right? So define print itself. Details of the child are self dot child underscore name and parent underscore name. Let's just call the child underscore one dot print underscore det function. Yeah, details of the child are Kevin and John, right? Uh, so that's basically single inheritance. All right, what I did was I took a parent, I took a child, and I inherited I inherited parameter from it, direct parent and child. Now let's do multiple inheritance. All right, multiple inheritance after single we have multiple inheritance. So that's like you can assume mother and father and then combining both of them. So what we'll do is we'll take heavy inspiration from the code above. We'll just copy this. We'll paste it here. We'll write multiple inheritance class. Let's make it father. All right, let's do this as father name, father name. Let's copy this and let's create a class for mother. All right, and let's call father and mother over here, and then we'll do child name, father name, mother name. Right, over here we'll just remove this. We'll copy this function. We'll be like father dot function name, and let's copy this function, mother dot this function, instead of child name to child, right? And then we can do Kevin, John, and any name. Ria is the one coming to mind. And let's run this. Yeah, you have to make it father over here. Let's copy this and it's over here. Details of the child are Kevin, John, and Ria. So that's how this multiple inheritance. I was able to take this this class, another class, and then combine them into one class. So father, mother, and child. Alright. Let's change this name or else this jack. So we are done with multiple inheritance as well. Now let's do multi-level inheritance. So multi-level inheritance, we'll again let's just copy paste this entire thing, alright? And we'll change it so that we don't waste time. Multi-level inheritance. What is multi-level inheritance? Grandfather, father, son. Alright. So let's do this. Let's keep father as it is. Let's change this to grandfather. Right. Right, and let's put this at the top. Now what the father init function will do is father will inherit from the grandfather, all right, and he will have his grandfather's name, all right, and he'll be like grandfather, and let's copy the init function from there. All right, fair enough. And then over here in the child we'll just be importing the father function, father class, and we'll have child name, father name, and grandfather name, right? and over here from the father init function, right? From the father init function, we'll also have to write this, then child name, and then over here we can do grandfather. All right. So Jack, John, and Johnny. All right. And if I were to run this, Jack, John, and Ron. Alright. So what we did was we created a grandfather class. We put the name of the grandfather over there. We created a father class. And we called the grandfather's name in it. We also defined the father's name in it. And then we created a child class where we called just the father. And because the father init function had already called the grandfather came with it automatically. Right. So father init function had the grandfather name in it. And then when we called the father function, both of them came together. Had I written over here something like father underscore one, and if I would have defined a father function, that would have become the singular inheritance, the first example, right? Now this is multi-level, all right? Father, grandfather, father, and son, and child, right? So that is done and dusted. And hierarchy inheritance. The best example of hierarchy inheritance is this one, all right, where we took a person and we split them into two, student and teacher. So I'll just do one thing. I'll just code it again in the form of this family relation so that you can understand it better. I'll take this code, all right. Let's make it hierarchical inheritance. Class father name is there. Then we create sister, all right, who takes inspiration from the father, all right. There's sister name, and then there's father name, and obviously we have to give a call to our father. So father dot this init function, all right. Then we just copy this and we replace all the sister in it with brother, right? Let's put brother over here, and uh, let's just remove this. We don't need this right now. What we can do over here is we can say uh, sis equals to sister, and then we can name her Priya. She's, let's say, and her dad's name is obviously gonna be let's say Jack, right? And then there will be bro equals to brother, and his name would be, let's say, John, and Jack would be his dad's name as well, right? Thanks for watching, guys. Leave a like if you enjoyed the video. Subscribe to see more of such tutorials. Give me a follow on Twitter at @KevinPKaria. And if you have any queries, feel free to send an email at ask.kevinpkaria@gmail.com.